Welcome back, everyone, to Security Weekly's virtual hacker summer camp. I am Paul Asadorian, excited to talk about how to effectively protect your users against ransomware and zero-day exploits. Here with me to talk about that is Danny Jenkins, the CEO of ThreatLocker. Danny, welcome.
Thank you, Paul, for having me.
Sorry, excuse me. Danny and I met at RSA. And I was intrigued with your approach to the problem, right? And you're really hitting on a theme that I've been talking about this week, which is, if your security revolves around regular expressions and blocking stuff with whitelists and blacklists, like you're having a tough time. And I'm always on the lookout for new technologies that get away from that filtering, blocking, and regular expressions. And Danny, I think you've built something spectacular that is definitely in my wheelhouse, right?
Yeah. So, the thing is on one side of the security spectrum, we're looking for threats. We're looking for things that are suspicious or acting badly. And it does a decent job in that it does reduce our risk. But the problem is equally, it keeps failing. And every year we see another hack, a new piece of malware, a new piece of ransomware, a new type of attack. And then there's the other side where you're talking about policy-driven stuff, where you're talking about absolutes. We're talking about blocking everything by default and controlling what can run. And the challenge has always been there is the management overhead on it. Is how do you deal with that? How do you deal with the fact that when you have an absolute, like I'm going to block everything that isn't trusted, and then an update gets released or a DLL gets recompiled, and that's really where ThreatLocker has really shined in that we've taken away from this guesswork of saying, well, I'm going to allow everything in the Windows folder, or I'm going to allow everything signed by Microsoft, and we take a whitelisting approach and then a ring fencing approach, but instead of just saying we're going to block all, we say we're going to block all, and then you choose what you want, which will help you learn. So you can say, okay, these are the apps we found, and we're going to match them with known apps. So when those vendors release updates, we're going to update those definitions. So instead of having a blacklist definition, we have a definition for Office and a definition for Zoom and a definition for 200 or 300 other apps. And you just choose which ones you want, and then we take care of all the hard stuff for you, in that we've got all the lists of those files and those hashes in them for you.
So ThreatLocker is helping me define known good, basically, right? At a very, very high level.
Yeah, and I like to call it known needed, because there is no, the line between good and bad is too hard nowadays. And if you take something like LogMeIn, it's a legitimate application. It's a proper company. They're not malware, but it's often weaponized and used against you. So if we say you choose what you want, and we help you define what it is. So this is LogMeIn. We're not here to say whether you should or shouldn't run it on. But if you need it in your environment, then allow it to run, because that will essentially has a business benefit. Versus if you don't need Office or you don't need LogMeIn, don't let it run, and then it can't be weaponized and used against you.
And if the runtime signature of that application changes, that's something that you monitor, correct?
Yes. So, and for the bulk of the stuff, everything from Windows updates to LogMeIn to TeamViewer, we monitor that continuously. So we have a lot of partnerships with a lot of companies, but we also have manual monitoring and then automatic monitoring. So if Google releases a new version of Chrome, we have processes that go off and say, oh, okay, Google released a new version of Chrome. Here's 40 new hashes that are required to run Chrome successfully. And then we'll download them, we'll add them to those definitions. So you say, I've got a policy to allow Chrome, it's still going to be allowed. And then we get into what that application can do as well. Because if you take something like, say, Angry Birds or Zoom, Zoom's a perfect example. That's allowed to run, and we know what files are required to run that. And if you look over the last 4 months, Zoom has released so many updates because of vulnerabilities. It's a constant, if you're taking that default deny approach, it's a constant challenge to find out what is the new update. But we take care of that for you. But we also tell you suggested policies on, okay, well, Zoom shouldn't be able to run PowerShell. Zoom shouldn't be able to access your files on your network shares. Right. So if by putting those policies in place, you essentially reduce the risk of something being weaponized, even when it is allowed to run, because you say this can do this and this, and it needs to stay in its lane.
Yeah, and so that takes care of process injection, right, which is still pretty common. Processes start injecting into each other that don't normally do that or aren't part of, the known needed functionality. That's something that you can prevent.
Yes, because first you want to stop things being able to access other apps, so it can't inject into the other app. But then you also want to stop it doing more than it needs to. So, and process injection comes up relatively frequently, but more frequently in the ransomware world is not necessarily even process injection, but someone running a PowerShell commandlet or running a regserve command to go out to the internet and run code in memory directly from a GitHub repository or something. And if you stop these applications going out to the internet, or at least going out to the internet except your trusted sites, and stop them accessing your files, I say it doesn't matter when it's being compromised. The impact of it being compromised is less likely to affect your business in a negative way. So, I mean, the first thing is don't let it run. And then if it is allowed to run, control what it can do, control how it interacts with other applications, control what it can do when it interacts with those when it wants to access your files. So if it does get compromised, like we saw Internet Explorer last year compromised, where you could run PowerShell commands from Internet Explorer, it can't call PowerShell, or PowerShell can't access your file. So it kind of makes it like a dud weapon.
Right. So it's almost like a sandbox for the application, but more in a policy sense.
Yeah, it's more of a granular sandbox for the application. So first of all, don't let it run, and then it doesn't need to be sandboxed, because if it's not running, it can't do any harm. The second thing is, once it is running, control what it can do. So almost sandbox it, but you can't just simply say, I'm going to sandbox Office, because Office needs to access your data. You can't sandbox QuickBooks, because QuickBooks needs to access your files, or Zoom, because it needs to do certain things. It needs to go to certain websites on the internet. But if you can do it at a policy level, where you say Zoom can access zoom.us, Zoom can access this file and this file, and Zoom can access this and nothing else.
And Zoom can't write to the System32 folder.
Yeah, it can't write to the System32 folder. And it's funny you mentioned that, because that's obviously comes up a lot in the security world. Now, Zoom shouldn't be able to write to the System32 folder anyway, because it shouldn't be elevated. That doesn't mean it isn't. But you can actually say Zoom can't access my network shares, which is a far bigger concern, because if someone compromises my System32 folder, they can maybe put new software in it, and they can modify files, which is bad. But if someone compromises my network data, my network shares, my documents folder, that's my data you're talking about. You can, whether it's encryption or whether it's theft, you've got my data. And you don't have to be an administrator. You don't have to be a local admin to run a piece of malware that can essentially copy all of your data and harvest it out to the web, or to encrypt all of your files on a network share.
Right. Yeah, and those are important controls, for a lot of reasons. Obviously, Zoom is a very well-connected application, right, and very popular today in that. So you want to restrict, and it doesn't need access to your data necessarily, right, in so many different cases. The writing to System32 actually squashes a local privilege escalation, a whole class of bugs that we talked about in a previous segment, which is why I brought it up. So now we can chain these together, and you can use Danny's ThreatLocker product to accomplish the mitigation that we talked about in a previous segment, which is awesome.
Thank you.
So what are some of the other use cases, Danny? Describe to me how someone has protected an application that may have caused them trouble in the past. Obviously, users need to use applications, so let's run with that example, that we're not just saying you can't run XYZ application. I want a user to run it, but how have they configured it to solve problems?
So my background's in enterprise IT, where we attempt and quite often use these whitelist types approach. And what often happens is you end up opening up entire folders because it's too complex, or make these really wide open rules with regular expressions or whatever it may be, because it's too complicated. So the traditional use case of whitelisting is you just deny everything, and that works very well traditionally on ATM machines and medical devices that never change, but it doesn't work on a desktop PC. So the first use case really is for ThreatLocker is we want to stop people running things they shouldn't do. We don't want users to run executables or DLLs or script files that aren't permitted by the organization. There's no business benefit, therefore we want to block it. The challenge has always been the update element, but also when they do want it, how difficult is it to approve? So if you think about traditional whitelisting, you say, okay, nothing's allowed to run. I go to join a call and it needs Zoom, and I don't have a policy to allow Zoom. And I can request permission and the administrator, and even on some of the most advanced, you see request permission. It says to the administrator, Danny's requested access to zoom.exe. So they say, okay, I'm going to approve that. And we do all that in seconds. But the challenge then is, well, what happens to the 104 dependencies that Zoom needs?
Right.
And they're not approved. So and that's where we've really, if you see the typical ThreatLocker use case, because we have all these built-in definitions, and then we have these learning modes and different functions like that as well, you can just say, okay, request permission, ThreatLocker knows what this is. We recognize this matches our definition for Zoom. Use our definition, we'll capture, we've got all the dependencies already captured, we know what they are, you allow it, we're going to put the policies in place that are accurate for you, and then we're going to use the ring fencing policy to make sure it can't do more than it's supposed to do. So what we see most companies that use ThreatLocker doing is they really take this approach that we want to control what runs in our environment, not just at the user level, but also at the kernel level. So if someone exploits something at the kernel or pushes it out through group policy, Active Directory, or SCCM, or ConnectWise Automate, or whatever it may be, it doesn't matter, because we're going to block it at the kernel level. And then when you want to approve new software, the security team or the IT team says, yes, I want to approve that. It's very simple. It takes 15 seconds. But we're going to approve it with these parameters around it. The other big use case we see is the ability to create policies to track and control access to storage. Because ultimately a lot of ransomware comes in the form of storage. And storage could be a USB drive. It could be as simple as you can't use USB drives that aren't encrypted. But it could also be a network share or a backup folder. So you can say, I have a backup folder here, and it hosts my Veeam backup on my backup software. I only want Veeam to be able to write to that folder or even access that folder. So you're controlling that access not just at a user level, but at an application level. So a user or an administrator can't inadvertently run something that's going to access that folder as a separate policy. And what we see most companies do is start off by denying everything that's not trusted. It is very, very simple. I mean, if you've ever used the traditional whitelisting, you'll appreciate when you see ThreatLocker how quick this is. And we've done 2,000 user deployments in an hour call for demo and deployment, and then an hour and a half call later on to do a review of the audit and lock it down. So that's how simple it is. Lock it down, don't let anything run. And then when something does run, only allow that software to access what it needs to, and then back that up with additional storage policies and things like that, where you can block access to writing to certain folders, whether they're network folders or System32 or whatever it may be.
Yeah, having been on both offense and defensive side, I totally see where you've made my job easier as a defender, right? Because I ran into the situation the other day, right? I was trying to whitelist a website, but it's got multiple domains that it's accessing that are all associated with this chat application. So I had to manually go, on block and figure it out. So you've taken away that level of administration, made it easier for me. From an attacker's perspective, you've made it very, very difficult for me to do anything, even if I do get on the system and raise the bar.
And that's really it. It's not about looking for every potential attack surface, because there are a lot of companies out there. I mean, you're at RSA, I was at RSA, and you walk from booth to booth to booth, and everybody tells you, we've got the best detection. We detect all the threats. Well, if that was true, there wouldn't be any ransomware,
right,
and there wouldn't be any threats. And you can't detect all the threats. And that's not to say that threat detection isn't important, but you don't put 3 house alarms on your house with motion sensors and glass breaking sensors and contact sensors and not lock your front door, because somebody can still walk in and take the TV off the wall. It's going to make a lot of noise, but they're still going to do that. So you've got to have a control element, and you've got to make it really hard from an attacker's point of view, that there's less surface area, there's less places they can attack, there's less ways they can get into your system. And the less ways they have to get into your system, the less likely they are going to do that. And then you're not hoping, going to bed at night, hoping that your antivirus is going to detect the latest piece of ransomware.
Right. Danny, great stuff. For folks that want to learn more and get a demo, you can go to securityweekly.com/ThreatLocker. Danny, thank you so much for appearing on Security Weekly.
Thank you, Paul, for having me.
With that, take a short break, come back with some more interviews. Stay tuned.